Let's review what we saw in the last episode about circular motion, so you can do this on your own. Let's draw here our computer screen. And we are going to create here a formula for our x variable and for our y variable. We want x and y to be different points on a circle here. So the first thing we need to decide is where is the center of our circle. We can pick, for example, the center of the screen, or we could pick a corner or any place, it doesn't matter. In this example, let's use here the center of the screen. So I'm gonna type here width divided by 2 and height divided by 2. So we start somewhere. We have to know which is the center of our circle. If we would use this formula, we would get all the time the same point, the center point. So we want to add something here. So at the beginning, we would just add something to the x value. So we would get this point here. Later, we would be adding a lot to the x value and then a little bit to the y value. So we're getting a different point. And as we rotate around this center, we are adding different values to x and y. Sometimes we are just adding to y, like here, or maybe subtracting from x. So we need some kind of function or a special formula to get all these points around the center. And we have seen that for that we use the cosine and the sine functions. And it takes one parameter. This parameter, I'm gonna call it a here, is the angle. That is, how much are we turning around the center point. We can say that if the angle is 0, we are starting at the right of our center. And as the angle increases, we are getting different points. If a would be something like 1, there would be somewhere here, maybe 2, and about 3, 4, 5, and 6. So if we want to make a complete turn, it's a little bit more than 6. And to be a little bit more precise, the number is 6.28 and more decimals. But instead of typing this number, what you can do is use a variable that processing provides, which is called 2pi, 2_pi. This number is 6.28 and more decimals. We can see it run here in a program, print 2_pi. So you can see down here the 6.2831855. And you can use this number if you need to make a complete turn around a point. If you want to start and stop exactly at the same place, use this variable. And we will see this in a moment. So we have here this formula. One part of the formula is defining the center of the circle. Then we are adding something. But we know that sine and cosine return numbers between -1 and +1. So that would mean that this is a really tiny circular motion. We want it actually to be at a certain distance from the center. So let's say, for example, here we have a distance of 200 pixels. You can choose whatever distance you want. It can be in pixels or 500. In this case, if it's 200, what we have to do is multiply this sine and cosine by 200. So you see that this number is the distance from the center. So that defines how large is this circle that is getting drawn. So that's the whole formula we need. Let's see this in action in a program. So I'm gonna define a variable for the angle. So it's float a equals 0. And then I'm going to do a while loop while a is less than 2pi. So we make one complete turn, and I'm going to increase a by 0.1. And now I'm gonna type these two formulas here. I'm gonna say float x is the width of the screen divided by 2. I haven't defined the size of the screen. I'm gonna do it here, size 500, 400. We are now at the center of the screen horizontally, and I'm going to add here cos or cosine of a and the radius, the distance from the center. This is the center, and this is how far from the center we are rotating. And here float y equals height divided by 2. So this is the center vertically, plus cosine of a times 200. So now we have this x and this y variable. We can do now whatever we want with them. We could draw circles there, for example. So I'm gonna do here an ellipse at x, y, and they are not going to be very big. So I'm gonna use just 10 and 10. And let's run the program and see what do we get. So there we have our collection of circles just drawn at once. This number here is the angle step, or how fast are we increasing. If I type here 1 instead of 0,1, we're gonna get much less circles because we are going to get to 2 pi much faster. We know that 2 pi, it's a little bit more than 6. So if we are starting at 0, we will have then a equal 1, 2, 3, 4, 5, 6, and that's it. So we are starting here at 0. Actually, it's going down, and I will explain now in a moment why. This would be 1, 2, 3, 4, 5, 6, and that's it. If we convert this into an animation, you will be able to see that it's going down instead of up. Let's do that. I'm gonna type here void setup. We'll declare the variable at the top of the program, float a equals 0, and then here void draw. And I'm now not going to use a while loop. I'm just going to be calculating this x and y position. I'm gonna draw the circle. I'm gonna increase the angle. And now I'm gonna check here if a is greater than 2 pi. Then let's stop the program. We can stop the program typing here no loop. When you execute no loop, the draw function is not called again. So it's the end of the program. So let's see now. Well, this is gonna happen really too fast. So I'm gonna make the angle a little bit smaller, 0.1. And you can see that it starts drawing down instead of up. And in our example here, I was saying that the angle here is 0 and it increases in this way. 1, 2, 3, 4, 5, 6. Why is it flipped in our program? Well, it happens that in math, in all math books, you will have the x and y axis, x and y, and they increase when going to the right and when moving up. So we could say here that we have 10, 20, 30, 40, the same thing up, 10, 20, 30, 40. The funny thing is processing, and actually every computer program assumes this to be the pixel 0, 0. Or I would say almost every program. And if we are taking as an example our program we just created, this would be here 500 pixels wide and 400 pixels high. And the numbers increase to the right and down. So this is, you can see here it's increasing down, and in math it increases when going up. So that's the reason why here in theory, in math, the angle increases when moving in this direction, moving in counterclockwise, and it goes up. But when we run the program, it's happening the other way around. We are starting here at the right border and it moves down. So now there's many different things you could try. You can play with the center. The center doesn't have to be constant. It doesn't have to be always on the same place. So imagine what would happen when you move the center to the right. In that case, you would start drawing a circle and you would get a spiral. You could do the same thing if you're defining the center of the circle with another circular motion. So imagine you're defining this x and y just to define this circle. And at the same time, you are drawing a circular motion around that. So you would get something like that. Or you could play with the radius, with this 200 here. Instead of having it fixed at 200, it could be moving. So you could be creating something like that. So let's add, just as a quick example of that, let's add some randomness here. So instead of using 200 fixed, I'm going to say random between 180 and 220. And actually, it would be good that both are equal for the x and for the y. So I'm going to actually declare a variable r. I'm going to say here float r equals random 180, 220. And what happens now? So now we have more or less a circle, but as we see, there is some randomness in it. So now you should have the basic idea of how you can create a circular motion or draw some objects in which you need positions that are spinning around one center. They have these three parts. There is the center of the circle, there is the angle, which is increasing or decreasing if you want to go in the opposite direction, and there is the radius, which is the distance from the center to the circle.